I'm going to be going through the communications section of the first chapter and giving a look at what we're going to be covering in communications over the course of the Year 11 or prelim course. So the first thing is we'll look at Copeland, and then we'll look at a set of notes that I provided, and then I'll look at some of the specific drawings that I have set for homework over the course of Year 11 last year. So before I get started, I just wanted to mention that I said, in this course we really should be prioritizing kilojoules because kilojoules are the SI unit. Kondo, she likes kilojoules, it sparks joy. I personally tend to think in calories, but that's just because I was raised that way. Probably a bad habit, better off thinking in terms of kilojoules. Certainly in terms of diet, I think in that. The big worth noting is that a calorie with a capital C is 1,000 kilojoules, which only confuses the issue. So that's why Drake doesn't like it. Okay, so where are we going to start? Well, this is probably as good a place to start as any. In engineering, we're often going to need to I don't want to do is make this big. We are often going to need to draw things. Mechanical engineers are probably the best example of they need to draw parts to be manufactured, but civil engineers obviously need to draw the things that need to be constructed. So for instance, it might be a concrete footing, might be a bridge, it might be a dam or retaining wall, could be the steel structure of a factory, all of those sorts of things. They'll be specified in drawings. Generally speaking, it would be very, very hard to specify our designs if we only had to use words. So most of the time we're going to use drawings. And most of the time, well, when we're going to draw a 3D object, there are different ways we can approach it. But generally what we're going to do is, we'll start with talking about 3D objects. What we call these in this course, we use the term pictorial to refer to 3D objects. And I have this closed passage here. Pictorial and orthogonal drawings. The benefit of orthogonal drawings over pictorial drawings is that they show more detail. Now, we haven't talked about orthogonal drawings yet, so that may be a bit, maybe not the best place to start, but so we're going to talk about orthogonal drawings in a second. But pictorial drawings, which is what we're focusing on here, they're drawn with one side at 45 degrees. So pictorial drawings that are drawn at 45 degrees are known as, with one side as 45 degrees, like this. So see how here, this angle here is 45 degrees? They're called oblique. And your oblique muscles are on your side. Oblique comes from the Latin word for slanted. And so you can think of these drawings as they're slanted. If I go to the next one, it says that, so the reason why we use oblique, sorry, I won't before I move on. The reason why we use oblique is because they're relatively easy to draw if only one side has anything interesting. So this is probably why a lot of maths teachers typically draw prisms as oblique drawings. Because if you need to draw something like a pentagonal prism or a hexagonal prism, it's a lot easier to draw that as, okay. Often, if you're drawing something unusual, it's easier to draw it in oblique if only one side is interesting. Okay, so the next one is pictorial drawings where both sides are drawn at 30 degrees. So here we can see this is drawn at 30 degrees, and this is drawn at 30 degrees from the horizontal. And that's called isometric. Isometric comes from, I don't know if it's Greek or Latin, but we're going to say one of those old languages that means equal measure. So that each of the sides is slanted at an equal amount. Iso meaning equal. There are some other words you may have heard that have the word iso in them. So like isothermic means equal temperature, or can't think of any at the moment. I'm stumbling on it, but I'm going to keep going. So these pictures where they're drawn at 30 degrees on either side, then referred to as isometric. These drawings look slightly more natural, and these are better when we have circles in two faces. So if we look down the bottom of this drawing, what we can see is two drawings. We can see an isometric and an oblique, and we can see how this circle is actually quite easy to draw. It just looks like a circle. The one on the top looks just like a normal circle, and the circle behind, easy to draw. It's this circle that is difficult to draw. right? We don't have any really good rules to draw that circle. We don't have any, we don't have templates that we can use to draw that circle. So that's the problem. With isometric, on the other hand, we can draw circles on any of the faces relatively easily. There are rules on how we can do it, and we can buy templates that will allow us to do it. So here I have a template, and typically we ask students, even in Year 9, to buy these templates. At the moment, 15% off. Those templates can make a big difference when you're drawing. Now, in the HSC, you probably are allowed to do a reasonable attempt at a freehand drawing of circles. These days, the HSC, compared to when I did it, you were allowed, well, when I did it, everyone brought in a drawing board and you were expected to produce a high quality drawing. These days, we understand that the main reason we draw 3D objects is to sketch. So we really just need something that is done fast and efficiently for the time that you have. So we'll come back to that in a second. So the last of the pictorial drawings is perspective. So pictorial drawings, okay, do we not talk about perspective? Okay, here we go. Perspective drawings appear the most natural. So when we look at perspective drawings, that looks the most like, if we were seeing an object in real life, it actually is far more likely to look, we see things in perspective. I remember when my daughter was very little, about 4, and trying to explain to her that the sun is the biggest thing that you can see. Well, the stars are even bigger, but I thought that was too hard a concept. And so she was only 4, and she said, well, no, but the sun looks very small. And I said, yeah, that's because it's just really, really, really far away. 4-year-old probably not ready for that sort of concept, but most people over time appreciate that people who are further away look smaller, and eventually they can understand the abstract concept of the sun being incredibly big, just far away. Obviously, there are stars that are bigger than the sun, but the reason why all 3 of these drawings are pictorial drawings: perspective, isometric, and oblique. We don't use perspective very often because perspective is hard to produce. So yeah, I said, we say here, they are hard to produce without a computer. So these days with Google SketchUp, we see a lot more perspective drawings, but we will not ask you to draw perspective drawings, or if we do, you'll never be asked to draw a perspective drawing in an exam. Perspective can be, with a perspective drawing board, it can be a good way to learn to sort of draw pictorial drawings. But the idea is that pictorial, because they look like a picture, they look like, if I said to you draw a house, most people are going to draw it in some sort of, especially if I said I want to see multiple sides of the house, they're going to draw a pictorial drawing rather than orthogonal drawing, which we're going to learn about in a second. So we like these drawings because they provide a lot of detail. So this is what I had up the top. Pictorial drawings, sorry, they don't provide a lot of detail. I'm not going to edit that out, but I'm going to say pictorial drawings give a good overview of the picture. When we look at a picture of a pictorial drawing, we have a good sense of it. Now, eventually, over time, engineers, and this is something that's hard for teachers to appreciate, is that over time, after 20 years of looking at orthogonal drawings, you do actually eventually just learn to see the orthogonal drawing, and kind of like Cypher in the Matrix, you no longer see the code, you just see the object. You can translate that, you can match up, and I'll show you. Here I have some homework where we have pictorial drawings on the top, and we have orthogonal drawings at the bottom, and eventually you just get to a point where you just can see this and know, you can look at one and just know that you can intuitively know what sort of shape it's going to look like. Which one is that? Matching it takes a little bit longer. I think it's E. Yeah, we'll talk about that in a second. Okay, so what have I got just before? Okay, so it's important to talk about, and this is the opportunity where I talk about what you're allowed to bring into the HSC. You are allowed to bring into the HSC a blue pen or black pen, a mechanical pencil, which back in my day was called a pacer, but these days with all the Japanese pens you can buy from Kinokuniya, mechanical pencil, you can which you use to draw thick dark lines. We'll talk about that in a second. You can use a HB pencil and a sharpener for which you use to draw dimensions and center lines. You can use a 2H pencil, which you should use to draw out your shape initially, to draw out sort of an outline, which we call construction lines. We haven't talked about those yet. You can bring in an eraser, a rule. Most people use the term ruler, but technically the more formal engineering term is a rule. You can bring in a scale, or what people would often call a scale ruler, and this can help you to draw things to scale quickly. This can be very useful when you're drawing vector diagrams, which the people who I'm recording this with haven't heard, but can be useful. And you can bring in a set of set squares. So just to quickly look, oh, that picture's not a big picture. Set squares, most people are familiar with what set squares look like. If I haven't shown you in class, I will show you what set squares look like. If I'd kept that Kent open, I don't care enough. Well, actually, I will give a quick recommendation. A set of set squares, compass, so compass for drawing circles, a protractor for measuring angles. That can be really useful. That can save you a lot of time. So, for instance, I have spoken to my Year 12 my students who have finished Year 11, who are now Year 12. I've talked to them about how when we have a scale drawing of a truss, often we have to use trigonometry to find angles, and that takes a couple of minutes. Well, maybe it takes a minute. And in an exam of only 180 minutes, spending a minute is losing efficiency. If you can instead just take a protractor, you're allowed, almost always, it will say that we can assume the drawing is to scale. I would argue, even if it says explicitly that the drawing is not to scale, you could still, in a pinch, if you were desperate, if you couldn't figure out the trigonometry, I would say you're better off just measuring it off and taking the drawing to scale than just sitting there and freaking out. You're allowed to bring in circle and ellipse templates, which is what I want to talk about in a second, and you're allowed to bring in an approved calculator. Now, the calculator you're using for maths will probably be an approved calculator. I wouldn't lose too much sleep about that. But graphing calculators, because of their computer powers, they can just store a lot of information. They might not be allowed. Okay, so this is an ellipse template, and ellipse templates, they can be used to draw these shapes here, these circles on an isometric drawing. So that's their value. I'm going to shout out to, when we talk about set squares, that I really like having a good set of set squares. So I recommend Kent set squares. And this is from when I was a kid at high school, that they don't have a bevel, which means that you can get a more accurate line a lot of the time with a parallax. They also have dimensions on both sides. Also, the dimensions go all the way into the corner. And I find all of those things to be big improvements. I also find that they're more durable and they tend not to break. If it was me, I would go for the biggest set squares, which means that they're going to be more expensive. That is definitely the case. They increase by cost at each size, but I just find having the biggest set squares means that you can draw across the whole page with one go. So that's what I would recommend. When you buy set squares, you're going to get a 45-degree set square, which is used for drawing oblique triangles, and you're going to get a 30-60 set of set squares, which we're going to draw for isometric. The important thing is that you do really want to have both, because often when you want to transfer an angle, you can slide one transfer, and I'll teach you how to do this in class, but you can slide one set of set squares over the other to transfer lines. So transfer the angle without having to redraw the angle. You can just, that's really important for vector addition. And yeah, you need both. Sometimes I have seen students where I have seen very few students bring in set squares into their Year 11 exam, or even their half yearlies. And let me tell you, I do not like this, right? That you need to have a set of set squares. If you can't afford set squares, I'll say this in this video, this recording, I have said to my students every year that if you cannot afford set squares, if you let me know, I will get you set squares. I will pay for those set squares out of my own money if I have to, but I will get you set squares. and I imagine that that's probably true for pretty much every teacher who is teaching engineering studies in New South Wales. What I don't want to see is I don't want to see someone who's bought a set of mathematical instruments, right? The ones in the tin or the ones in the plastic that you buy from the Office Works for like $4. I don't really want to see those. You need to have a good set of set squares to be able to do drawings in this subject. Okay. Lastly, before I close this window, is how to draw isometric circles. So what I have here is I don't teach this anymore. I learned how to do this when I was a kid, and now I say that for those students who really want to be able to produce their own isometric circles, there is a method for doing it, and luckily we have YouTube, which will show you how to do it. And if someone says to me that I've watched the YouTube video and I still don't quite get it, I'm more than happy to help them. But the reality is that anyone who is going into that much effort, I would say to them, just buy the circle templates. Again, if a student said to me, I just cannot afford circle templates, I would see to it that they got circle templates. I've been saying this now for 3 or 4 years, and I have never had a student come up and ask for. It's not to discourage anyone. I'm saying that I'm welcoming students coming and letting me know that they don't have that. If price is an issue, I'm happy to lend out set squares for the year, rather than have students not be able to adequately attempt drawings. Okay, so what I will say is, let's see what we've got next. Okay, the next thing we're going to talk about is orthogonal drawings. Now, orthogonal drawings are really important. When we can see orthogonal drawings, can you see how there's 3 versions of each picture? Yeah, we've got a top view, front view, and a side view. And from those 3 drawings, we can use that together to piece together. I was going to ask a question, but I can't remember what the question was. Anyway, we have a top view, front view, and side view. And from those 3 views, we can piece together what the object should look like. Now, generally, I would say that it's faster to draw an orthogonal drawing than it is to draw an isometric drawing, or even any pictorial drawing. I would say it's generally faster. But more importantly than it being faster, we can show a lot more detail on an orthogonal drawing. To help you remember the names, orthogonal means, well, what's an example of where you've heard the word ortho before? Yeah, so the orthodontist, well, they straighten your dons, right? And so for kids who have done French, les dents, D-E-N-T, is different to the D-O-N. But so maybe you've heard of an iguanodon. Iguanodon is a dinosaur that they first found the tooth, and they said that it looked like an iguana tooth, but much bigger. So iguanodon, iguana tooth. Don means dentist. So don means tooth in Greek. So an orthodontist, what do they do to your teeth? They straighten it. A lot of people say they fix your teeth. No, that's a dentist. An orthodontist, they straighten your teeth. So ortho means straight. What about gone? Where have you heard the word gone before? Something gone. Okay, like maybe you've heard something like hexagon or pentagon. You've heard those words before? They're familiar? What does gone mean in that context? A hexagon has hex what's? Sides. 6 sides. Pentagon has 5 sides. When we put those words together, orthogonal, what does that mean? Ortho and gon, orthogonal, what do you think that might mean? Straight sides. So what it means is we're looking straight on each side. We're looking at the top, the front, and the side. Now, there are different ways that we can draw orthogonal drawings. In Australia, we use something called third angle projection, not first angle projection. And so we have these 2 different symbols. So this symbol here that I've drawn, by hand, that is what the symbol for third angle projection. How I remember these symbols, because I teach this, I have to remember it, right? I can't just take a guess at it. I remember it as the picture looks like a target and a flag. A target and a flag. You're okay with that concept? That this looks like a target and this looks a bit like a flag. Yep, flapping in perspective. In third angle, the target comes first. Third angle starts with a T, target starts with a T. Yeah? In first angle, what they use in Stinky France Now, I always say stinky, stinky France. The fact is, I like France. I'd live in France if my wife would let me. But in France and the European EU, in most English-speaking countries, we use third angle. In the EU, they tend to use, I don't know about their legislation, but they use first angle. Now, we might say, why don't we use first angle? First angle sounds better, but no, in Australia, we use third angle, and I'll explain why. In France, they use first angle. So see how it's the flag for first, yeah, target for third. We good with that? If you have to remember how to draw the flag, I remember that the flag looks a bit like a a less than sign. That helps me to remember. That's how I remember to draw it. Now, that's a freehand drawing of this symbol. I might be able to find that symbol in a second for you. But here's the reason. In Australia, we use third angle, and the third angle means we put the top view on top. So in Australia, we use third, that starts with a T, top view on top, and a target. See how all those strings have a T? Third angle, top view, target is the picture. Yeah. In France, they don't put the top view in front. They put the front view in front. The front view on top. Right? Now that's confusing to me. I think Australia has it right, where we put the top view on the top, and then the front view below it. In France, they do the opposite. In France, everything is surrounding the top view, right? And so that's maybe confusing when I said it. But the idea is that if we imagine our shape, and teachers often have this, I may or may not have this set up for my class who's listening to this. What we often do is we get a couple of pieces of acrylic, and we imagine that the object that we're looking at is in a glass box. And what we do is we take that object in the glass box and we draw what we can see. So like we're looking at a camera, we can see that this piece of glass that's lying horizontal, that's on the top, you can see that what that object can see is this shape. If they took a camera, that's what they see, is this shape. Are we okay with that? And then the piece of acrylic or the piece of glass that can see here, what it can see is the front view, and it looks like the L shape. And so when we put those two together, when we fold the box open, what we produce when we fold the box open is when we fold the box open, what we'll get is third angle projection. Whereas a way of thinking about it in first angle projection, and I try not to talk too much about first angle because I think that just confuses people, is the idea is you start with looking at the object on the flat, and then you rotate the object. I don't like that concept. I try not to think about that concept too much. It hurts my brain. Luckily, I don't live in stinky France, so I don't have to use first angle. I use superior, third angle projection, and that is the case in most English-speaking countries. So if your goal is to live in America or the UK, then you'll be fine. So what we're going to do is we're going to draw the first thing we're going to draw is we're going to draw the top view on top, and then we're going to draw the front view below it, and then we're going to draw the side views on either side of the front view. And that's the key, that the side view lines up with the front view. And this makes a lot of sense when you're thinking about a house. If you're drawing a house, we want to see a drawing of the house on the top, the plan, and then we want to look at side views. We want to look at the main side view, what we maybe call like the north side view, depending on the orientation of the house. And then we want to look at the east side view. And we can look at the house by looking at different positions. Now, what's really important, and where a lot of students lose marks, is that students don't line these views up. The top view, can you see how the top view is perfectly aligned with the front view? And can you see how the side view is perfectly aligned with the front view? That's really important. That's how we approach it. And how we do that is by extending this line across, and can you see how it hits an imaginary 45-degree line and then drops down. Now, wherever we put this 45-degree line will decide how far away our object is, right? How far away our side view is. But really, as long as we draw a 45-degree line, this will work. And what I have is a lot of students, two things that they get wrong is that they don't put the top view on top, and they don't have them line up. Now, I don't know how many times I need to say that to students, but they don't seem to think about it very often. Okay, so now's a good opportunity to talk about testing. Now, obviously, everyone is concerned about the HSC and what they... I just wanted to get this back because I remember I had a question, and unfortunately, there's no great way of pausing. Am I logged in as my channel?
I've done quite a bit of technical drawing, and I was just looking at videos on YouTube and like tutorials on other sites and that. And there's a lot of roundabout, sketchy ways of doing it. And I just thought I'd share this with.
Okay, so my video with the most views is me going through a preliminary, not a preliminary, a half-yearly exam question on how to draw a toaster. And at least it had the most views when I made it. Okay, so in this video I talk about how, and so this is where if someone wants a more detailed explanation of how to draw orthogonal drawings, this video is a good opportunity, a good example of how to do that. Well, I mean, tooting my own horn, I said it's a good example. It's an example that's going to be representative of how I'm going to mark. I probably shouldn't have closed, but anyway, it's done now. Okay, was there a question? I have the answers to the closed passage above. The other advantage of these two angles tends to be when we're doing trusses later in the year, that almost all of the trusses we draw also happen to be at 45 degrees or 60 degrees. And that's not by accident. We tend to design things to those angles. That's quite common in practice, and those diagrams can help you. Also, the maths is a lot easier for those numbers, so people are typically fairly familiar with those numbers. Okay, so I'll just quickly recap. We'll go over this again. The benefit of orthogonal views, the reason why we use orthogonal views is they can provide the most information. But pictorial views, which we see here, 1, 2, 3, the reason why we use pictorial views is because they give people a good overall sense of how to draw, what the thing looks like. They give you a good starting point. They give it good context before you start going into the details. It's also very useful, I would say most of the time where we use isometric or oblique drawings is that is when we want to first start talking to a client. We might start with an isometric drawing because it gives the client a good understanding of what it is we're going to produce. So that's where I'd say the big advantage is, and this is where sketching is a really important skill for engineers. I can definitely say that in my working life, being able to sketch has definitely been an important part of my job, and in my particular company, engineers didn't do much CAD work. Instead, they would hand that work over to draftspeople, and they were just more efficient. So what we would do is we'd hand over sketches and they'd be able to interpret our sketches. So sketching, really important skill. Okay, so which brings me to the subject and subject of how we mark this in the HSC. In the HSC, sketching will be worth a varying amount, but I would say it's probably going to be worth, on average, about 10 marks. About 10% of the exam is going to be on drawings. There will almost always be what we call a threaded section, right? A threaded orthogonal drawing. So we might have to draw, it's a little bit complicated and maybe too far to go into at the moment. Almost always be a drawing on those. Now, I'm recording this in 2021, and prior to this year, prior to a couple of months ago, I had said to students that there had not been an isometric drawing in well over 5 years. Yeah, I think I can say that, well over 5 years. I think the last one was in like 2013 or 2014 or something like that. There hadn't been one since. Now, a lot of people would say, well, maybe that means we're overdue, or I was thinking perhaps it just means that we're no longer, as the HSC, we're no longer prioritizing this. Now, I will say that it takes a lot of time to teach drawing skills. So a lot of kids who have done graphics in year 9 and 10, they've got an advantage. The kids who have done architecture or engineering as an elective in year 9 and 10, they also usually have an advantage. But for other kids, they often get really concerned and stressed about drawings because drawings represent a lot of effort for only maybe 10 marks on average. So when I say 10 marks, what there might be is there might be a 6-mark orthogonal drawing typically, and there might be what we call developments, which I'm not going to go into in this video because that's year 12 content. There might be 4 marks of developments, or there might be something on sectioning, or there might be something which asks you to match up an isometric drawing, something along those lines. The fact that in the 2020 HSC there was a 6-mark isometric drawing was definitely a concern for a lot of students. I haven't looked at we haven't seen the HSC data yet to see how many students did well on that, but I can't imagine it was many. And the fact that a lot of my students don't even buy a set of set squares means that a lot of my students, I cannot convince them that they need to take drawings as a serious and reliable part of the HSC. My attitude is that in the HSC, there's only a few things that are very likely to be in there. One of those things is that there will very likely be a truss. There's about a 90% chance there'll be a truss, and I'd say there's a 100% chance there'll be a reaction. So to the people who are listening to this, they've learned how to do reactions and they have some understanding of trusses. Trusses are another thing that students tend not to do well. And my response to that is, this is the thing you know is going to be in the test. Rather than preparing for all the things that might be in the test, you should prepare for the thing that is absolutely likely to be in the test. And you need to work through, if it's uncomfortable, you need to continue to work through it until you get to the point where you can say, okay, I've at least got that 3 or 4, maybe 5 marks. Sometimes the last 2 years it's been 6 marks worth of trusses in the bag. And there could very likely be 6 marks worth of threaded orthogonal sections. And it probably doesn't hurt to have a rough idea of how to draw some isometric drawings. So this is why increasingly I make them set for homework throughout the year, just so that I can say that we have covered past HSE drawings. Okay, so that's a rough idea of how many marks these are likely to be. And now we're going to talk about, so the first homework that I usually give kids when students when they're learning about drawings is this here, where I ask them to match up the different drawings. So I said before that I think that 1 matches up with E. Can you see how E has a long top, like we see here, and E has these dotted lines. These dotted lines here are hidden detail. That means that there's something inside that we can't see from the outside. So when we look at it from the outside, it just looks like an L shape. You can see that L shape. But the dotted line means that inside, further into the drawing, there's something going on in the middle. And we call that hidden detail. Now, I might come back to this video when I've talked a little bit more about hidden detail. We'll come back and we might go through those answers. But I usually ask students to first to identify them for homework, and then I ask them to draw each of these shapes, just to get to used to the practice of drawing things. You can buy isometric paper that helps you to draw these shapes. It's lined already, so you don't need your set square. And if each of these shapes is sort of, I say you just take them each as 1 block. So this is here would be, it's not exactly right, but I would say this is 1, 2 inside, and then 1. So that makes this top one here 4. It's actually probably like 3.5, but no, I don't need to get into that triviality. So we can just call that 4 by 3, that block. And most students are happy with that. So, okay, the next thing we need to talk about is dimensioning, but before we get to that, we're going to talk to line types. And before we get to line types, we'll just quickly cover what, so I think we've covered Copeland and his explanation. He talks about freehand sketching. So freehand sketching is a really important skill. Being able to draw without instruments at all is really important, because most of the time you're not going to have instruments. And then being able to use set squares to help you freehand is really useful. Often, almost always, and so I marked a drawing question last year, and I can't say officially, but I'm pretty confident that people who didn't use a ruler but who made a reasonable attempt at freehand sketching would still have not been penalized in a 3-mark question. In a larger question, you might. It does say, if it says the word sketch, you're allowed to just freehand, but even then I would recommend that if you should have set squares, and you should take them into the exam and use them. So that my recommendation is absolutely that you should be using set squares, because you don't know if the individual marker is going to, how they're going to feel about whether or not your freehanding is of adequate quality to be to get full marks. Okay, so what we have here is I have an extract from the Victorian Technical Drawing Specification resource. So this is for, like, in Victoria, they don't have the HSC, they have a VCE. And in the VCE, they have a subject, I think it's called, like, some sort of technical design or something like that. And in that, they have a manual, which we can see here, that gives a very good standard for drawing that you can use as a resource. Now, obviously, it's not a HSC resource, but it's pretty close. VCE is about as close as we're going to get. Now, when we do drawings, we're going to have two line weights. We're going to have thick and thin. Now, the Australian standard, which I'm going to talk about in a second. So, there is a standard. So, the Australian government endorses and often refers to a set of rules and regulations that have been defined by an organisation called Standards Australia. And this applies for many things. So, for instance, for concrete design, are you required? For concrete design in Australia, almost every engineer, I would be struggling to think of why an engineer wouldn't use, maybe if they weren't designing something for Australia, engineers in Australia would use the AS 3600, which is the Australian standard for concrete design. For if you're building a house, I believe it's 1694, something like that, the timber framing code. There are a variety of standards. Now, I'll stick with the concrete code, or the bridge code is the 5100, the AS 5100. I think electrical installation is the AS 3000. Gives you a rough idea of there's different codes for different things. When we're using these codes, that if you're doing work for pretty much anyone who knows what they're doing, they will specify that all designs must comply with this standard. So if you're designing something for a government, the government is going to say that all designs must comply with a relevant standard. So that covers them. They can say you have to design to the concrete code. So if I haven't designed from the concrete code and I haven't notified the client, I haven't modified the contract conditions, then I could be liable for any costs. And certainly, if someone dies as a result of my design, I would have to argue in court how I wasn't being negligent. Now, I suppose I consider situations where a client might say that they want us to deviate from the standard because the thing we're using is going to go into space, for example. But that's a pretty niche consideration. Also, if you're designing overseas, you might have to work to their local standard instead. A lot of the time, the Australian standards are also applicable in New Zealand, so they're often ASNZ standards. But the standard for in Australia for drawing is the AS 1100. So that means that all of the drawings that we use in a technical engineering context, and sometimes in other contexts, should comply with this standard, the AS 1100. I'm going to show you some of the AS 1100 that I have selectively used to make examples. These documents, you do have to buy these documents. They're not freely available, so keep that in mind. Okay, so the Victorian government gives a good summary. So the first thing they say is that you should have different line widths. There's a thick dark line and there's thick dashed lines. Now, I would have to find this, but I'm pretty sure that in the Australian standard, we should always be using 0.5 thick dark lines. That our thick dark lines should be 0.5 thick.